I'm here with Dominic and Zubran on the Siemens booth looking at electrical digital twin. Guys, what are you up to?
Many companies and many players out there are using the name digital twin, right? So there are so many digital twins. Let's make sure we talk about the same thing here.
Correct.
What is our understanding of the digital twin first? So if we have a look at the whole power grid, you could actually have a perspective of an asset twin. You could define a digital twin for a power transformer. You could define a digital twin for a substation, for example.
A specific device or a collection of devices.
Exactly. Siemens is doing that. We're working on this also with Bentley. The focus, what we want to have in the beginning for our discussion is actually, but quite the opposite. We want to look at the whole system, a grid-wide twin, so to say. This will be our starting point for the discussion, if that's fine for you.
So a grid-wide twin. Keep going.
So what we understand with this is actually two parts. Number one, in our understanding, a grid-wide twin should all be about data management. It's a digital representation of the data in the grid, not of all the details like you would have it in the asset twin, but of the most important parameters of the most important assets. This is part one. And then part two is really what do you do with the data, right? Simulation, analysis, analytics. So it's always those two components that we have in mind when we talk about a digital twin.
Okay. So how do I make all this real?
How do you make this real? The main idea that we have and the vision that we're actually sharing, both Bentley and ourselves from Siemens, is actually what you see here. In a typical utility, our customers that we talk to, TSOs, DSOs, these guys do have many different departments. There's an operations department, planning department, they have GIS, meter data management, and so on. So all of these departments typically do have, just historically, their own digital model of the power grid.
True.
However, there's only one physical grid out there, right? In reality, there's only one physical grid. So our main idea is basically, if we want to talk digital twin, we define one digital twin for the power system. And the idea is to put it in the middle as the single source of truth for the network model management data. And then all the different departments that we see in a utility can, and that's our vision, high level speaking, can then exchange data with this one source in the middle.
Everyone uses the
one digital twin.
One digital twin.
Exactly.
So I also know that this is it's not a destination, it's a journey. That's basically what it is. We know. I mean, I read in Forbes that 90% of the data was created in the last 2 years.
90%.
90%. That's a huge amount. That's all the IoT that's there.
Because the stuff is now being connected.
Exactly. Now, what we also are very conscious about is that the utility companies, they are trying to transform whilst maintaining high degree of performance.
Yep.
Right? So how do you go about doing that and being on that journey? So it's not a switch. It's like, hey, buy this big thing and it's going to solve all your problem. We want to complement, supplement their existing solutions that they have. A big problem with the digital twin is, with the silos, is the dark data, and it's a term that I think Gartner came up with, right? Which there might be data in the GIS that is specific to that particular department, but the planning guys have exactly.
Nobody knows about it. Nobody can use it. They don't even know.
Exactly the point.
I don't know what I don't know.
Yeah, which is then compounded by the fact that they're working in silos, right? So the return on investment is obviously by giving them that aha moment, saying, oh, I didn't know I could use that and apply the planning data with my GIS data, right? The third thing that I see is happening is that the pace of decision making is increasing tremendously.
Has to.
Right, because it's not now. It's beyond that 5 year and 6 years planning that they have to do. You just got to, as ad hoc planning now, right? Which means they got to have.
If you look at what you guys are doing with electric vehicle charging, so somebody decides we're putting in chargers in the grid now, not in 5 years,
That's true.
next month.
And that has
what the hell does that do for my grid balance?
Right.
So these are those type of questions which kind of trigger thinking in this direction. Actually, what we discussed and what we share as a vision, as the customer benefit out of this is, I think, something we should really highlight again. If we have duplicate data models here, it's going to be a lot of maintenance and data management effort. If we have the data here once, we just have to do it once. Of course, there's the upfront integration and so on that needs to be done, and then you need to synchronize and so on, but that's basically our main value proposition for this increase in efficiency in data management.
Electrical digital twin is the grid digital twin. It's not
It is,
the box.
it is the grid digital twin.
I'm going to add a spin to this, right? One of the things that we are seeing here is, obviously there is a performance aspect to it, right? There's a performance digital, we call it performance digital. We can label it as performance digital twin because it's an operational mode. It's a brownfield situation where that you want to sort of capture. But at the same time, new assets are being created, right? Which has an impact on your performance digital twin. And both twins needs to coexist and share. So it's you know.
So I think one thing is about really sharing data with the digital twin idea. The other thing is, if you're as one of the departments, suddenly you might be the planning department, and then with this digital twin idea, you might be able then to use data from other departments, meter data or GIS data and so on. This will enable now suddenly also new use cases that you can think of. Combining data sources, combining tools from the one side with data from the other side.
But it's the classic thing of, I don't know what data the other guys have. I didn't even know they had that.
Correct.
Exactly.
And now that I know they have it, now what could I do with it?
Exactly.
I don't know what I don't know, right?
Exactly.
As opposed to, I do know what I do not know.
So that is why it's a journey and not a destination.
Right. What does this look like in the real world?
So I think we should really show the two examples, the two companies have been working on together to make it a bit real.
Because I like slides, but
of course.
Meanwhile, in the real world.
So let us show you one example. It's the DER optioneering. Should I start or?
Explain the context and why we went there, right?
So a typical use case is, imagine you're a DSO.
Yep.
You do use your GIS system to know what's happening in your grids, and now you get interconnection requests of your end customers for their DERs that they want to integrate in the system. Yep. So there might be someone who wants to integrate a solar panel, and now he asks the DSO, will it be fine? Will it be fine to integrate it here? So the question that the DSO has is, will the grid be stable afterwards? And this is exactly what we're doing here. There's the GIS system, which is typically not able to do any analysis of stability and reliability of the grid. It just tells you where stuff is. Exactly.
Right, so it should tell you where stuff is.
So in the digital twin idea, now we take this GIS data and we take tools from the planning phase, actually, which is calculation engines that can calculate stability, and we integrate this in one workflow, so that you can now, as a DSO, answer the stability question and then just give an answer to your end customer.
Energy storage or PV or whatever here, what's going to happen with the feeder line, with the substation, whatever.
Yeah, and a great thing about this is it frees up valuable resources. You don't need like really high, expensive resources to do an interconnection study, right? I mean, you do that when some mediation is required, but to get
something massive.
Exactly.
But with the deployment rate increasing of DERs, you just simply couldn't. The cost would be prohibitive. Time.
Our customers are telling us they get a few thousand requests per week. Some of them even per day. So there is no way around automation,
exactly.
right?
You got it. Yeah.
This is exactly what this is. And look, this is now the new button. This is now. Somebody wants to install distributed generation here, puts in some parameters, and then they click the run button, and this is the new thing. This is integrating the simulations
approved
with the GIS.
Because somebody has set up some criteria that will it be within these bounds, and that's based on the knowledge of someone who runs the grid.
Exactly.
If you see a fail, you can still drag in a very advanced engineer to then export the model to sync up.
Why did it fail?
Exactly.
And maybe it's I need to upgrade this piece or whatever, right?
Right.
So this is one example of bringing together GIS with simulation engines via this digital twin idea. One example. I think we can also show another one, right?
Yeah. Do you want to go into that brownfield use case? So another example is you have a substation with aging assets. The documentation is, well, in
somewhere.
Some
drawer.
So what we've done here is establish trying to get a digital context of what is out there right now.
Okay.
Helping them identify what they have. And this is not just a pretty picture. We are then saying that object that we have identified is a conductor bank, just identifying it.
We're talking photometrics, LiDAR scanning.
Correct, LiDAR, photogrammetry, creating a reality mesh.
Okay,
right?
so
it's giving a digital
real
context.
world
exactly.
representation.
But that's pretty. But now we're making intelligent by saying, okay, that object there is that asset ID through that asset tag that sits in my asset management system. Suddenly the world opens up. You get, you're like, oh, I'm now associating my tabular data set that I have to a digital context. Right, and once you have that, you can then, the world's your oyster. You can then plug in telemetry data. You can add in, what your work orders. You can sort of say how much work orders has been done. This Siemens uses this from a servitization perspective. They said, right, we want to help our customers to resolve the situations, their issues much faster. How do I do that?
Yeah.
I want to see through the eyes of my customer, right? And this helps them do that.
So in the ideal world, I could, okay, it's a demo, video, whatever, but basically, the pretty picture, I can click on something, I'm associating it with an asset.
Yeah.
Correct.
It'll pull
Correct.
up the relevant material. If I need a spare part, where do I get
Correct.
what it is, yada, yada, yada.
Exactly, and we're going with this. We started with the grid twin. This is almost going then into an asset twin dimension, right?
Well, it's
a
bringing
substation twin, so to
Correct.
say, and then you can discuss where do you need for this brownfield substation services. Then you can drag in Siemens colleagues to do the service and so on. Where integrated, call Siemens button or something.
Exactly.
Well, so, I spend a lot of my time looking at, in the past, drones and, get all the low orbit satellites, and you have the augmented reality, or body cams and whatever. And it's really cool, but the thing was, people were saying, well, I've got all this data and I've got a LiDAR scan of my entire power station. Now what the hell do I do with it?
Yeah.
Right?
Yeah.
That was the next trick. So this is where electrical digital twin starts coming.
This is quite useful. The use cases are, just so many of it. Like remote inspection is another one, right? So you have like substations in a cave somewhere or middle of the desert, and do I send resources there to sort of know what equipments I need to fix what I need to do?
Or the guy goes there and he brings all his spare parts and he opens the thing and it's like wrong spare part.
Yeah. I mean, so
That's true.
Costs money. Even rolling a truck to a substation in a city costs money. And if I have to go back there, that's more money.
Right. So it just gives that immersive experience to a user, and by doing this, this is what I mean by establishing that bridge to all other your data sources that you have.
Yeah.
Right.
Well, and I'm guessing with the utilities and stuff that you guys are working with, this journey is just starting, right? You were on about a journey.
I think actually, Zubs, you made an important point there. We do have a starting point with our customers. We start discussing our vision of the digital twin.
Yeah.
Obviously, you cannot have a digital twin right now. You cannot buy 13 kilogram of electrical digital twin, right? This will not work. So we will start with small implementation projects, proof of concept work. We do have some things that we can already today bring to the table.
You build it up as you go.
Exactly.
And
step by step. This is the journey that he mentioned, which is actually super important.
And the other thing being is that you start step by step using some of the data you already have.
Correct.
It's not that I have to
Yes,
go out
yes.
and
Absolutely
I have
right.
to buy LiDAR
Absolutely.
scanners and a drone guys and
Absolutely
whatever,
right.
right?
Absolutely
so
right.
use what you have, but get the value out of what you have.
So this gives you, if we step back and see what it gives us digital representation of our assets, right? So you can do historical, current, and predict future as well. right? With using your existing system of records that you already have. So that's
Hey, good stuff, guys. Thank you very much.
Kevin, it was great talking
cheers,
to you.
Kevin.
Thanks a lot.